So you've likely noticed this theme. It's a recurring theme in math education. You learn some algebra, you learn some arithmetic, or you learn some geometry. You practice with basic problems, which are just numbers and letters or shapes on an assignment, and then you learn how to apply that knowledge to something that makes sense in the real world. Some kind of application problem, or often some kind of story problem. This is no different, and as in most of those problems, the challenge is typically extracting the equation or the shape or the arithmetic problem from the story problem. Once you get to that point, you're usually in comfortable territory because of the practice that you have done using similar problems. Let's begin this. Example problem number 2, using rational equations. A flight across the US takes longer east to west than it does west to east. Assume that winds are constant in the eastward direction. When flying westward, the headwind decreases the plane's speed. When flying eastward, the tailwind increases its speed. The time for a round trip shown is 7 3/4 hours. If the airplane cruises at 480 miles per hour, what is the speed of the wind? Well, let's let x be the variable to represent our wind speed. That'll be our unknown quantity and also the quantity that we're trying to solve for. We know that rate times time equals distance. Therefore, we could solve that equation for time to find time equals distance divided by rate. The table outlines nicely for us the different ways to write distance, rate, and time once for each of our 2 legs of the trip. When going west to east, the distance is 1,850 miles. Notice that's the same as going east to west. The rate, when going west to east, 480 plus x. Remember, we have a tailwind in that case that's increasing the rate of the airplane's flight. And when going east to west, a rate of 480 minus x. Going against that headwind slows down the plane. The time taken, as we saw above, time will be distance divided by rate. In our case, 1,850 divided by 480 plus x when traveling one direction, and 1,850 divided by 480 minus x when traveling in the opposite direction. The book does a really nice job of laying out the process of solving this problem. They've even color-coded some things for us. It looks like they've color-coded a least common denominator that we're going to multiply both sides of the equation by, and then they walk you through the process of simplifying. Works well also. I will check my answer against the book's answer when we're done to make sure that I've done the problem correctly. Of course, if I didn't do the problem correctly, I will edit that out and you'll never know. So the first step is to write the equation. And as I said before, that's often the most difficult part of completing a story problem, deriving the problem from the story. So in this case, we have a round trip time of 7 3/4 hours, written in decimal form, that's 7.75. And then we had the times of each of our 2 legs of the trip. I've written those here. Notice now we're to the point where we should be pretty familiar with. We need to solve for x. We're going to utilize least common denominators. We're going to do some multiplication and then simplifying and probably figure out what x equals. The first of those steps is to identify the least common denominator. Notice on the left-hand side of the equation, we have a denominator of 1. Right? We can think of 7.75 as being 7.75 over 1. And then on the right-hand side, we have 2 different denominators, 480 plus x and 480 minus x. This tells us our least common denominator will be all 3 of our denominators multiplied. So 1 times 480 plus x times 480 minus x. So there we have it. Least common denominator equals denominator times denominator times denominator. And of course, I didn't really need to write this 1 here. Recall the identity property of multiplication. Multiplying by 1 doesn't change a number, or in this case, an expression's value. So what next? Well, we need to multiply all 3 terms. So both sides of the equation, which means all 3 terms, by our least common denominator. And here that work is shown. And notice we immediately find some things that are going to cancel out for us. We have 480 plus x, not written very carefully, 480 plus x in the denominator here, and 480 plus x being multiplied by the numerator there. Similarly, and now we can multiply and begin to simplify. So just rewriting the equation without the canceled out portions, we find this equation. And so now we begin the process of actually performing some of the multiplication. Multiplying or foiling our binomials on the left. Recall first, outer, inner, and last. And completing some additional multiplication, we arrive at this equation. Further multiplying by distributing the 7.75 on the left, combining like terms on the right, seeing some cancellation, we arrive at this equation. And from there it's a matter of solving for x using inverse operations. So I will first subtract 1,785,600 from 1,776,000 and then divide both sides of the equation by negative 7.75 and finally apply the square root to both sides of the equation. So solving for x, we find positive or negative 35. Remember, this is the speed of wind in miles per hour. But keep in mind, in the context of this problem, negative 35 miles per hour doesn't make any sense for us. So we're going to go with 35 miles per hour as a good approximation. And I could pretend to take a peek back at the last page, but I actually did that while I wasn't recording and I'm already confident in my answer. So 35 is correct, but to check this, we would simply do what we often do in algebra and check by substituting the value 35 in 4x in the original equation. In the interest of time on the video and your time, I'm not going to do that. Just trust me, it would work. The book verifies that for us. And let's move on. And here we are at the got it question for this problem. Parts A and B. Let's begin with A. You ride your bike to a store 4 miles away to pick up things for dinner. When there is no wind, you ride at 10 miles per hour. Today your trip to the store and back took 1 hour. What was the speed of the wind today? And part B, a reasoning question. Explain why there is no difference between the travel time to and from the store when there's no wind.